So good evening and welcome to a new food4Rhino webinar. Today we have a very nice set of speakers with us. They are going to talk about Omniverse, about what is Omniverse, and what is how you can do collaborative design and simulation, and how you can connect Omniverse with Rhino. 1 second. How you can do collaborative design and simulation, and how you can connect. Yeah, and well, we have different speakers with us. As they are a big group today, I won't read their biographies, but you can find them on the description of the webinar, so that you know they all have vast experience in the AEC market, in animation, in programming, in visualization. So we have with us Sebastian Misurek, Robert Cervellon, Cobus Bothma, Krista Glanville, and Tom Riley. And yeah, they will start by presenting what's Nvidia Omniverse, then some case studies, then a live demo with the Rhino connector. And at the end, there will be like 15-20 minutes of QA. Feel free to use the chat you will find on the right side of your screen. And then I will collect some questions will be answered there live by the Nvidia Omniverse team. And the rest of the questions, I will place this to the speakers at the end of the webinar so that they can answer all of them. So thank you again. Thank you, Nvidia Omniverse team, for doing this webinar. And yeah, we are eager to see what you have to show us.
Excellent. Thank you, Carlos, and thank you, food4Rhino and McNeel, for having us. So today we're going to present on collaborative design and simulation at scale. So first is our safe harbor statement here, just to put that up on screen. And so today, as Carlos mentioned, we're joined by Krista Glanville, Cobus Bothma, and myself. And our team is, as was already mentioned, all come from the architecture and AEC industry with vast experience. George is our team manager. And then we have Jay and Robert, who all have experience in design visualization, computation, and a lot of different things, especially using Rhino for many years. So let's take a look at why we're talking about Omniverse today. And so 3D design is a pretty complex sport, as we all know. And so we have a few different challenges that we're trying to address. And so we have large scales of teams working together of different backgrounds, different expertise, different skill levels that we're trying to bring together. On top of that, we're all trying to collaborate and use many different pieces of software. And sometimes they tend to be silos versus working together. So we're trying to bring that into one place. And then we also have, the growing complexity of our 3D worlds that not only go to visualization and 3D modeling, but to AI simulation and all of the different techniques that we are working towards as our world gets more complex and more digital. And so we're working primarily in the AEC market. However, at Omniverse, we're working with many different companies, individuals, and organizations in the media and entertainment space, as well as product and manufacturing, scientific visualization, robotics, and autonomous vehicles. All of these industries are all trying to move towards lots of either metaverse applications, digital applications, and bringing all of those 3D silos together. And that's where we're trying to make an impact. So let's take a quick look. Krista will take us through what Omniverse is, and first with a video.
Omniverse technology will transform the way you create.
Okay, so that was a really beautiful video that showcases all of the different industries that Omniverse is impacting, but we want to talk a little bit more about what this means for design collaboration and how it works for design collaboration. The three key pieces here are Nucleus at the center of the screen, which is the brains of the operation. And then we have Kit, which is where we build apps like Create and View, and Connectors, which is what connects Omniverse to your favorite app like Rhino. So the idea here is if you're a client, you can have information streamed to you from many different formats, from a headset, a phone, or a tablet. The Viz experts and designers, they all have their specialized apps like Maya, 3ds Max, Rhino, and Grasshopper. And the project leaders are a little bit more like the clients. They're a little more hands-off. They're not necessarily doing things in the apps, but they still want to see the project. So the center of all of that work is Nucleus. It's what's linking all of these different personas together, as well as linking all of these different apps that people are using through the connectors, through apps built on Kit like Create and View. They're all talking to each other. So we're not limiting what you're allowed to use. We're really trying to open it up for more collaboration and more enhanced collaboration. You can pull data in from multiple sources and push it out to multiple sources like VR or AR. I don't know, Kobus, if you wanted to add anything to this screen.
Yeah, no, I think that's great. I mean, I think the main thing to understand here is that we're using an open format, USD, and Omniverse is really the eye or enabler to that open format, and that allows data from, as Krista mentioned, multi-applications to stream in, but not just into Omniverse, but also out from Omniverse. So it's an enabler between applications that's best suited for the particular task that the designer needs to perform.
Yeah, and so speaking of USD, USD is the foundation for Omniverse. USD stands for Universal Scene Description. We think of it as the HTML of digital worlds. It was invented by Pixar over a decade ago, and it's all open source. And that framework lends itself to being really easily extensible and super flexible. As the data is getting converted over to USD, there's no data loss whatsoever, whether it's metadata or geometric data. It's all interoperable from different third parties, and it's all non-destructive through this concept of layering. And it's what accelerates this time to production, because you're all working under a singular format where you're able to see edits and iterations in real time without having to move massive data sets. So it really is the foundation of Omniverse. And then on the other side of that, we have MDL, which stands for Material Definition Language. It was developed by Nvidia, and Omniverse will take your materials from whatever app you're using and convert them over to MDL so that you're also using a standardized material package as you're working through everything. MDL is also open source, and it's able to represent physically accurate materials, which is key for accurate simulations. So you have materials behaving as they're actually supposed to behave in your reality. And then connecting to Omniverse, next, we've got the video. We've got the video of the launcher, which is our library of our various apps that we created for Omniverse on Kit. We also have connectors, which connect the pieces of software like Rhino back to Omniverse by pushing data out to USD. And you can use those connectors live, so you don't have to hit an export button. It all just happens in real time. And we have third-party extensions and content packs available as well. And this ecosystem is always growing. Our aim here is to connect everyone in their favorite app to each other through Omniverse. I think so far this year, we're at 150 connections total, and we can import just about any format. So next, Sebastian's going to talk a little bit more about the Rhino connector specifically.
Interesting. Yeah, so within our Rhino connector, that's kind of what we're here to talk about. And so within here, we have multiple export and import options. So you're exporting geometry, materials, lights, UV mapping, many different things from Rhino into a USD file to bring that into Create or View, any one of our applications. And then on top of that, we also have USD import. So you're able to natively, through the connector, import a USD file. And so that way, if someone creates something in Revit or Maya or SketchUp, exports that to USD, I can bring that into Rhino. Additionally, we have a Grasshopper connector, which allows us to, which has a few different nodes that allows us to export that geometry, and that could be actual geometry from Rhino or Grasshopper. And then we also have lighting nodes and a few other things. So we can also export simulation meshes and other sorts of data. And so the thing that really makes this quite interesting when we look at it in context of a platform like Rhino is that we can use this also as an aggregator. So using the USD layers, we're able to put things together and bring all of our files together like we kind of couldn't in any other platform. And so that means that we're able to take our Rhino files, and so we can have an Omniverse project, which can be multiple Rhino files, whether that's a single user all working together or multiple different users working at the same time in the same file. Additionally, we can then open that up to our colleagues or ourselves in terms of using other files like 3ds Max and Revit and SketchUp, and all working collaboratively together. And so to take a look at that in Rhino itself, so you have a connector, you're able to export this as a USD file. And so we're able to see this live workflow where we do link up our Rhino model into our application like Create. And we have the staircase here where that staircase is actually living inside of a Revit model. And so as we make some changes in Rhino, we're able to see that on the other side live within Create. Additionally, we have the ability to change this all in Grasshopper as well. So we love our use of parametric tools and parametric models and computational tools. And so Grasshopper really allows us to Create allows us to extend Grasshopper and all of the things we can do. So in this particular example, on the left side, we have one of our colleagues who's based in New York working in Rhino and Grasshopper. And then they're streaming their model live to our other colleague who's in California. And the model and building that they're in was a base building from Revit. And you can see we can change the geometry live. We can change lighting and colors and all sorts of information. And then that shows up in a nice full fidelity image on the right side. Additionally, we have other tools that make the Rhino connector really powerful, one of them being asset swap. So in this particular case, we're taking things like trees, and on the back end, on the Rhino side, we have these very simplified versions of that. So we don't have very heavy geometry in a Rhino scene. We're using the power of something like Grasshopper to be able to create some variety and create some nice trees and change within there. But on the back end, we're using a CSV file to do an asset swap and create trees. And so in this one, we're swapping these out for trees, but any USD file is possible. It can be from our library, but it could also be something that you create custom, whether that's an asset or that's something like an entire building or city. So you can be able to swap those out as needed. Another aspect that's really important is collaboration. So we can be working together with our files live, but at the same time, we can experience this in many different ways. So what you have within this scene is on the right side, I'm in Rhino in Grasshopper. On the left, we have Create, so we're able to see my design changes live for this pergola. And then in the smaller screen in the middle is my colleague in Seattle, and she's in a VR headset looking around. So you're able to now in real time stream that data to your VR headset. So not only are we making design changes, but we're making design changes collaboratively, live, and much more quicker. And so that means instead of making a Grasshopper change, baking that out, saving it, rendering it, putting it in a presentation, and then presenting it, we can put all of that into a much quicker live workflow. And so those are the kind of basics of some of the things that we can do with Rhino. And let's see how we can put all of that together in our design story that Cobus is going to tell us.
Great. Thank you very much. I think that kind of has an intro to where Omniverse sits within Rhino and the use of Rhino and Grasshopper in it. But as we started off this conversation, it was quite clear that, of course, our industry has multiple workflows, multiple applications that we all need to know. And the importance is that we use the tools best suited for the job. I mean, that's a critical part of where we are moving towards the future. So here we have Revit. We have a pseudo project that we're setting up here. We have Revit here, and you can see we're doing the typical BIM functions within Revit, building the building up, doing the facades, the cores, etc. And then we go ahead and we export that as USD into Omniverse. And you'll be able to see that live running into Omniverse. Now, this will form the basis of a building where we can do our main programming and facades and the likes. You'll also note that USD carries not just geometry, not just materials, definitions, and the likes, but also data. So we can carry the full fidelity Revit model, the full fidelity BIM model, into an Omniverse scene. We also have the ability to bring in the plans, for example, in their specific locations. So when we start collating this model with multi-applications, with Revit and Rhino and SketchUp and the likes, we have a full view, a full understanding of where the project is going to and the needs for the project and how we need to respond in the separate applications to build this project up. Of course, there's also functions like sectioning tools and the likes that we can run through. So here's another designer that prefers to use SketchUp. We'll get to the reason behind all this. This is all good. But this designer has the ability to do the interior designs and layouts of apartments for this building and export these various apartment types as SketchUp models to Omniverse using USD. And as Sebastian mentioned earlier, the USD then resides within Omniverse on Nucleus, and we have the ability to leverage this data from various applications in the way we assemble our buildings as such. Once the geometries come in and the materials and everything is coming, of course, within Omniverse, we have the ability to adjust, to tweak, to add high fidelity materials, to do some changes, add assets, etc. to this model. So where does this fit in with Rhino and Grasshopper? Well, we use computational modeling quite extensively in Rhino, and with Grasshopper, we're running here, for example, an optimized model of an apartment building to answer the requirements for the different unit types. These are blocks that we're placing in Grasshopper, and we can do the mixes and apply the mixes and do multi-variations of how we want to distribute these apartment blocks. But we do not want all the detailed geometry in those apartment blocks. Go next one. So what we're doing is we do a live exchange with the detail models in Omniverse. This allows us to use computation and computation functions within Rhino and Grasshopper to its best purpose and let the other applications exchange as we go into Omniverse here. So here you can see exactly the same model A101 that's been exchanged with a high detail model in Omniverse itself. And I'll show you the three different types of apartments. And you'll see that the representation on the left that we place in Rhino is exactly represented as full detail fidelity models on the right-hand side. These models come from SketchUp with additional assets added to them, including lighting and all the layouts and all the variations we want to build into it. And of course, that then allows us to take our computational model and apply it to a full building model to have variations of apartment layouts in full detail. So we don't need to be limited or overload an application where it's not needed. We use the application that's best, functions in the applications that's best suited for it, and then exchange it with high definition or higher assets from other applications. So the same with this, for example, we have now the apartment layout. We're doing some of the facade configurations and tweaking in Grasshopper as well. So I'm editing a curve here that adjust the facades, and we're creating 3 or 4 different facade topologies as we typically do in design. And that allows us to collate these with variants in Omniverse and then have the ability to exchange between these. So we can actually look at this in a high fidelity real-time model that we can spin around and sort of adjust or flick between these different options and different facade types and the likes. Now, bear in mind, these are USD files that's being linked in as options, which means that if the designer do tweaks and changes, we'll see those changes reflect as options as well. And then, of course, we also have the ability to go, as we showed earlier on this project, to go live. So I'm editing some geometry on the left-hand side here, and Sebastian, who's sitting in New York, I'm sitting in London, is getting those live updates, not just as a Rhino or a Grasshopper rendered model, but a model that is made up of SketchUp, Revit, 3ds Max, and Rhino and Grasshopper. I can change materials, and again, Sebastian on the other side of the Atlantic will see those material changes in real time. All right, so he has the ability to look at all the geometry together while I focus on my task, which is getting the geometry for the facade optimized for the purpose for the building. And as you can see here again, we may want to have a longer overhang at the corner there because we have a bar and restaurant in that corner, and we may want to have some more shading as such. So we're putting that geometry forward, it adjusts the geometry, and again, Sebastian sees the update hundreds of miles away. All right. Now, the great thing about this, of course, is you guys skipped it, is that we can override materials. So Sebastian can go and actually override materials in this model. And the important thing about USD, which is very, very, very critical. Sorry, just go a little forward there. You just scrolled a bit forward, sorry. What is very important is that USD is non-destructive. So while I'm doing my edits and changes in geometry, Sebastian can go and actually change material options and material variations on that without doing anything to my geometry. And once he's applied those materials on top of it, I can keep updating my geometry and he'll see the reflected materials. You can almost see it as a Photoshop layered option where he's applying the layers on top, and that takes precedence on top of everything else without destroying the source file that I'm editing at the moment. And this is quite an amazing pipeline and process, because we can have 3 or 4 variations in terms of material of this geometry controlled by one geometry set from Grasshopper as such. All good.
Then very similar to what's happening on the exterior of the building, we have other designers working in parallel on the interior. So here we're seeing a Rhino file being sent to Create, where it's live updating inside of a larger Create file that's actually a compilation of a bunch of different Rhino files, as well as some assets from various asset libraries. And the key thing here, like Cobus mentioned with the exterior, is the designer can keep working in Rhino, and meanwhile the interior designer or the visualization specialist can start adding materials and building out the scene in Create. And later on, when we push new geometry to Create, all of those material changes are maintained because they're built on a USD layer that lives above the rest of the geometry. You can probably skip ahead this one, yeah. So going back to that designer, they're still working on a soffit piece in the restaurant. So what you're seeing here is actually 2 people working collaboratively in real time. This is all recorded simultaneously. I'm in the top left in Create, and I'm sitting in Seattle, and Sebastian is controlling the Grasshopper script from New York. And that script is being pushed out live to Omniverse and brought in as a layer inside that larger restaurant scene, so that we can start to see how the scale of these fluted pieces feel in the space, and we can start to make informed design decisions while the visualization specialist is still working in the scene.
Yeah, and the great thing about the USD layers, as we mentioned earlier, is that all of those changes can be made in a non-destructive format. So however we change materials or whatever changes we make to the scene, I'm taking my Grasshopper file that I'm exporting and I'm linking it into Krista's file of this beautiful restaurant. And so it really allows all of the disciplines that have different skills to work together.
And here we're going back to the power of optioneering through variants. So we can look at various options for the countertop material. In a minute, we'll see some different lighting options. And when you have clients that say, oh, I like that countertop, but with that lighting, you don't need to go back to your desk to re-render anything. You can trigger all of those changes in real time, and you can mix and match until you have an outcome that everyone's happy with. And as Cobus mentioned earlier, all these options are still linked to their source files. It can all still be updated live. The lights here are actually being pulled from a Grasshopper script and tied to IES profiles. So if someone went and changed the intensity of that lighting behind the scenes, you would see that change the next time we switch over to that variant in this file.
That's great. So that's basically how we can assemble a multi-file. But I want to show you a bit more how we can work with other applications using Rhino and the likes. So here you can see one of the applications that has bidirectionality. So on the right-hand side, we have Omniverse. On the left-hand side, we have 3ds Max. The right-hand side is made up of Revit, Rhino, Max, SketchUp, and the likes. And you can see while I'm editing in Omniverse, the user on the left-hand side actually see those changes. Now, because we're dealing with bidirectionality and USD, the user on the left-hand side can very easily reference in our Grasshopper or our Rhino geometry as well to do some of the functions that's best suited in their applications or the application that they actually know of. Similarly, as we've shown with Rhino on the left-hand side, you can author that in the DCC and you'll see the updates happen in Omniverse on the live. So more and more of these applications are starting to become bidirectional. So we can actually have a specific function like we're doing here in 3ds Max, collate with multiple other applications that typically would not speak together. They would typically have to import or export or translate, and there's always fidelity loss and quality loss of the files itself and so forth. But now we're dealing with a full fidelity, full resolution model on the right-hand side with the bidirectionality into the applications. And here just back to R, just to show you the variations, and we're flicking through variations here to show the different facade options, the different unit options, and different interior options that we've done on this pseudo project. And I want to take this a little further because now we get to a point with variations or variants as such, where we almost have a building configurator. So if you look at like a car configurator as such, because here we can actually start exchanging between slab configurations, facade configurations, as well as apartment mixes. And the permutation or the multiplication of all these variations would mean that we'll have to render 20, 30, 40 plus renderings and stick them up or look at them on a screen. But now we have the ability to live swap between these variations. So if we want, say, the apartment mix 1B with facade type 2B, for example, we can go and review that and have a look at it. If we want to look at different landscapes or lobby options with different facade options, we can go and do that. And of course, because this is extendable and Omniverse is super extendable on top of that, one of our colleagues has built a counter here. So we can actually exchange between the mixes and get the count back of the typical unit types per building, which is very, very powerful when you start breaking that in a granular point and using Omniverse almost as a configurator to answer the need for the client.
Which is really important when, making design decisions with your client, with your boss, with whoever it is that you're working with, all the kind of stakeholders. Because lots of times we're in our process having to, swap out, turn off layers, turn on layers, make some renderings, try and coordinate everything. But you could also think of it as an extension of the design presentation process.
Yeah, and just to reiterate what Krista also mentioned before is that because these are USDs that are live loaded, that when we exchange between apartments, for example, and a designer has done a change in that layout, you will see that live. There's no reason to go rebake, rebuild, re-optimize or anything. Everything is running live from the DCC, from where the author is of that actual package or design stage as such. So of course, we can take Grasshopper a little further as well and extend it with functions like Ladybug and Honeybee, where we can do some generative modeling to find out the best building sizes for sites. And we'll be able to take that from Grasshopper directly into Omniverse as a geometry animation and an analysis animation as such. This allows us to get full understanding of a site, not just as a diagram or a diagrammatic representation of it, but as a full rendering and allowing us to do complex overlays of, say, detailed Revit and Rhino and Grasshopper models with our analysis models to get a better feel for it. Diagrams are quite good if you look at it in a way, but if you get the full understanding of it, a full simulation model that is true to real life, it is much more convincing to the clients and to the seniors of the design projects as such. We also have other connectors. So from within Omniverse itself, and also from Rhino, of course, we can publish to applications like SimScale, that's the CFD application. And now once we've done the CFD compute, we can take this in a post-processor like ParaView, and we have a live link from ParaView into Omniverse itself. So we can do some of the post-processing, like slicing it and creating streamlines as such, and then bring that back into the visualization model, which means we now have the ability to not use just a singular analysis application as such, but multiple analysis application, as we see here, using Rhino and Grasshopper and some of the Ladybug Honeybee functions within it to get the diagrams out and the analysis, as well as some of the CFD functions that are available to us, to be able to get a comprehensive picture of what the nature is of our site and what the understanding of the environmental impact is on our site and what we should best do to our site to get the best building out. As such. I'll get it over now to Sebastian to show a little bit about how we can even extend this further.
Thank you, Kobus. Yeah, so as you can see, we've got a lot of applications coming together. We have different ways of representing that and showing that. Another way is through our Create XR toolkit. And so we mentioned VR earlier, but we could also look at this in AR. So lots of times we're working with either clients or colleagues, and they don't necessarily need to be in the application, but how can we show them that design and go through changes and make different updates for them to understand? So what we see in this video is myself in Create, and then we have my colleague Jay, who's in California, and he's on his iPad in that bottom right video, or this video, and he's basically in Create XR on an iPad, and he's looking at the building, and then I'm using what was mentioned as the variant tool in order to flip through these different facade options. So this becomes a really powerful tool, because one, they can set it up on their conference room table, living room, wherever they want, walk around with their application and take a look at the project, look at the light. We can change lots of different variations within here, and then be able to see all of that information together. So you're not only focusing on, oh, the client didn't see that rendering, or I wish I could see it from a different angle. But if you're working through all of these different design options, showing your client, working through a variety of different things, this allows you to really be in that space, whether it's in an immersive experience like VR or in an immersive experience like XR or AR. And so that way you're able to see all of these variations. By looking around, we can see how the light plays with the materials and the space and so on. And you're able to kind of flip through that in real time and have someone else take a look at that, which kind of brings us to some of our other cloud options where we're building out. They're kind of in beta right now, but we're building out a whole host of different applications, from being able to share and send your client a link to being able to run and open Omniverse within cloud applications, whether you prefer to run it locally or in the clouds. Those will be kind of options coming soon.
Sorry, Sebastian. Yeah, I just want to reiterate this as well, because I think it's very important that whoever's perceiving the building in its full assembly here, as you can see it on screen, has the ability to interact with it and make decisions in a natural and a comfortable environment. And one of the ways we see this is by picking up a tablet. Some clients put on headsets or someone to actually stream it to a lightweight device through a web platform, so we can actually open a web browser and stream a full fidelity model. Also, what to understand here is that this is a fully ray trace model. Our base level of rendering is actually ray tracing, which is one of the highest levels of rendering you can do. So when you're in VR or when you're in AR, you'll actually see true reflections and true material qualities in this model, which is another bonus. And there's no optimization again, or no pre-baking or anything we need to do. This is all live directly from Rhino and Grasshopper and the other DCC applications.
Yep. And so to kind of bring the points home, really, it's about collaboration. So that, from one of the first slides where we talked about 3D being a kind of complex sport, and we need to bring everything together. So within this sample project we have here, we have this building open in Create. We have a base building that's built out in Revit. We have McNeel, Rhino and Grasshopper for our facade. We've built up these apartments in SketchUp. We've use the 3ds Max assets and libraries and interconnectivity, as well as our own assets within Omniverse. And one of the really important points to bring home here is this not only just helps with teams working together, but this could even be with staffing. So you're not worried about, oh, does that team member know Revit, or do they know Rhino, or they can all work collaboratively in their platform, because what we're trying to do is, or what the designers are trying to do, is bring design home, right? We're trying to make that presentation. We shouldn't be so worried about all of the applications if we can bring them all together in a much more kind of intuitive and better visualized way. And so throughout this project, we use a number of different apps that are part of the Omniverse Kit application suite, as well as all of the ones you see here from City Engine. We didn't really quite get into, but all of our context was built out in City Engine and brought directly into Omniverse straight from ParaView, all of the simulation data, and all of the tools that we went over specifically. And so to wrap up, that's kind of where we're at now. So we'll kind of open it for questions. But before we do that, in order to get your hands on Omniverse, you can go straight directly to food4Rhino, where we have a series of different links and information. So there you have more in-depth hands-on tutorials in terms of how to bring geometry in from Rhino or Revit or any of your applications that you're working in. So you can go to those tutorials. We have a whole playlist of different links within there that'll take you through very step-by-step instructions on installing it, going through, selecting your geometry, exporting it, opening up, and then working through it. So we have a kind of vast library of things within there. So you can find that either searching Omniverse online, or food4Rhino has a great number of different links and some more information there. So I think we'll thank you very much for the opportunity of the presentation, and we'll open it up for questions.
Wow, many thanks, Sebastian, Krista, Kobus for the presentation. It seems the future is here already. The video was amazing, also the live demo. The chat was on fire. Thanks to Robert and George for monitoring it. Many questions, and in different ways. I think you have also planned a workshop. I don't know if it's for the Thornton Tomasetti Hackathon or for the Chicago Innovate, or for both.
Both those.
If anyone is interested in more hands-on demos with us, so we're going to be presenting next week at Chicago Innovate Tech Conference, and so that's going to be a hands-on workshop. And then we have 2 weeks after that, in early November, we have two hands-on workshops for this kind of the basics of getting up and running with Omniverse, which is like 3-hour workshops. And then we have an extended one that's going to be a little bit more advanced about creating different extensions, programming, connecting it to more advanced tools like Rhino Compute and so on. So that way you're able to run Rhino Grasshopper scripts inside of Omniverse through running Rhino Compute. So there's some more advanced stuff we didn't quite get to today, but we will be a series of hands-on workshops. So if you're not familiar, or in the Chicago area or New York area, please join us. We'd be happy to meet you in person, and we'll be giving a series of presentations there as well. So it's Chicago Innovate Tech, and then AEC Tech in New York.
Great.
It's something worth mentioning as well, that Robert's been working on, and that's of course extending Omniverse to Rhino Compute. During the workshops, he'll go into some of that, but it just shows that actually the application is not there just for the visualization. The visualization is realistic because we need to simulate worlds, but we now have the ability with Rhino Compute to be able to compute on this. So you can actually build, and he'll show you some stuff. You can actually build facades on geometry generated in Unreal Engine using Rhino Compute and using Rhino Grasshopper, which before could not be done because we didn't have this interoperability. We didn't have this open central source and application like Omniverse to be able to interchange between these. Incidentally, Unreal, 3ds Max, and Maya are bi-directional. So, I mean, Rhino stuff that goes into Omniverse will be able to go into those and compute back into it again as well. So it's a different way of thinking about it. It's really, really great.
Wow, amazing. well, the McNeel US team will be also at those two conferences.
Awesome.
And I guess they will also participate at your workshops or contribute with anything you need from compute. Actually, that was one of the questions, if it was fully bidirectional, Rhino and Omniverse. And well, I think Robert or George already answered that it's not yet.
Yeah.
But yeah,
We can,
as you mentioned now.
Yeah, so we have a few bidirectional connectors. Rhino is not yet at the moment, but there are plans for that. And so importing everything from Rhino into Omniverse, geometry, as we mentioned, materials and so on. And then within importing, we're able to get, file hierarchy and things like that. So it worked out quite well, and it's been fun to use it as a bidirectional or kind of interoperability tool as well. So if someone's working in SketchUp, I don't necessarily need to then bring that in or break that down, but let's bring that in as USD, make some changes, export that out as well. And so the bidirectionality, once we get that going in Rhino, I think that's going to open up some really crazy
Could it be possible
workflows.
maybe through Speckle in the future, or
we have a Speckle connector as well. We can bring the data across. So it's all done. I mean, we can import, but bidirectionally will happen definitely. Yeah, it'll happen in the future. The bigger part of it that we're very excited about is the ability, as we've shown as well, is to really leverage multi-applications through Rhino and Grasshopper, because you're actually just using the USD file format and be able to distribute and populate that. I think the tree was a great example of exchanging assets as such, and the ability for us to be able to use someone's SketchUp model and just place them randomly, and that person working in SketchUp can be updating those apartments while we're updating the Grasshopper distribution of those apartments. And that's just a case study, right, that we are looking at.
That's really great.
It really becomes an open platform. You use the tools you want and design the way you want. We don't want to be teaching new software every day, right? We want to use the great software that we have. And
also the collaboration with Unreal, because yes, that's a question many people have, and they also place the same question to the Unreal guys.
Absolutely.
And it's very nice that you collaborate.
Yeah,
because it's something so new. People are still maybe thinking who will own the metaverse or Omniverse or whatever.
I don't think anybody will own it. And let's get that clear. I think the important thing here is that, say, for example, the SketchUp model comes across and we have a Rhino model coming across. We can control that concrete looks like the concrete we want to from all these different sources: Revit, Rhino, SketchUp, and the likes. And the great thing is in Unreal then is that we have this connector live database into Unreal. So when the assets go in there, it's the right concrete. Right, and they can build the applications on top of that. But that's the function of Omniverse. It really makes this one single authoring world that you can then take the data out into the applications that you want to use it for, or stay within Omniverse. And like we showed, with the one click, you stream data live at ray trace quality across the states to an iPad. Right. So
there's so many fantastic applications that have their what they're best suited for, and I don't think any company wants to extend that across every single application or build in all those features, into one application. So linking things up, having people that are working on animations or character rigging while someone, is working on a drawing set and someone's working on building out a very detailed table or lamp, I think is the beauty of it. And it's really about putting it together. So we're not only working in small snippets of renderings and, flipping through some PDFs with our clients, but how can we start to, make design changes quicker through using all of these applications together, but bring it into a more immersive experience with that.
And the performance was impressive. From what George or Robert answered, you were using in your demo one GPU only, and RTX or?
We use the RTX, the A6000s. Yeah. So the big thing with GPU to understand is that, and this is the great thing about it, is that the bigger your model becomes, you can scale. You can really scale to multiple GPUs, and this is also where we're working with providers, which allows you to spin up GPUs and spin down GPUs as you need, depending on the scale. We've loaded the whole of London model before on a single GPU and be able to spin it around as such. So your ability to get that full simulation quality on a machine is doable, absolutely doable.
So it's twofold. It's trying to make the optimization, as good as possible, but without spending any time on it from the designer standpoint. So you don't have to decimate models, retexture stuff, working with a lot of different technologies. We can do that within Omniverse, but at the same time, once you do kind of start to hit those limits, with large buildings, large systems, cities, and so on, once we're starting to look at much larger data sets in terms of that, then you can start scaling up your hardware as needed, right? And so that way, Omniverse is a multi-GPU kind of scaling engine in terms of its visualization power and simulation.
And do you provide that service yourself, this multi-GPU, maybe on the cloud, or?
Great question.
I don't think it's in beta. It's not out yet. So yeah, it's in beta.
Those will be services available.
The very important thing about that as well, Carlos, just to add to that, because we get these questions quite a bit. The deployment of this is kind of threefold. You can run Nucleo as the server on your own machine in your own office, right? We give it to you. I mean, you purchase it and you deploy it. It's your data, your way. And you can also run that in your own cloud, so on one of the cloud providers. We don't intervene. We don't know what you do with it. We don't care what you do as long as you do your job, right? That's very important. And in the future, we will be looking at a sort of SaaS approach where we can actually provide you these services and so forth. But the important part of this is that we don't want to be involved in your business. We want you to make your business better. So we're going to provide you the software, and you're going to control everything you do about it. We have no connection to it at all in any way, which makes it really great for you to extend that and build Omniverse, because we mentioned the extendability of Omniverse to the specific functions that you want to do. So you might be in retail and you want to have specific functions built on top of that. And by the way, by building extensions, this is writing Python and side by side, and you see what you write coming up into Omniverse. If you're into a footwear design, for example, you can build custom footwear. We've built configurators for warehouses to train robotics. So click a button and it builds a complete warehouse with real physics in it and so forth. Those are all the extendable side of things that you can do on top of Omniverse. That's going to be your IP and your sort of gain on the industry. So that's really great. And it's a really amazing platform it's not a product, it's a platform to develop on top of. So.
Right. And George or Robert also mentioned you have a program for developers, right?
Yeah, absolutely.
Well?
Yeah.
And at this Discord channel, I guess it's both for users and developers as well.
Yeah.
I think Robert is posting those links on the chat and the links to the next training sessions in Chicago and New York. What else? I mean, actually, again, Robert and George answer most of the questions
they
there.
good at it.
And the chat list is so long now that I don't know where to start, but everything was covered there. Some people ask if they can, maybe they join the webinar late, and well, it's being recorded automatically, and it will be available right after it finishes on this same link. I posted also there the playlist of all the food4Rhino webinars. What else? Great job. Congratulations.
Thank you.
Some people also asking if it works with Houdini, Revit,
yep.
SketchUp,
absolutely,
other programs. And the nice thing is that the users of all of these different programs can work together on Omniverse, right? And do their change on the parts they are responsible of. Yeah, internally, Robert was telling you if you can show Rhino Insight or Rhino Compute. I don't know if you could show something now or maybe in a future webinar.
At this time, we can definitely show it. Let me quickly just find the video. So.
Yeah, and in terms of getting started, we do have, if you're an architecture company, we have Omniverse Enterprise, so you can, for large organizations, whatever it is. But for individuals, if you just want to get started with it, we have Omniverse Individual. So that way, if you go to the link on the food4Rhino, so we're all familiar with food4Rhino. We download all our favorite plugins from there. And so if you search Omniverse on there, there's a direct link on how to get started with Omniverse. And so that's going to take you to the page where you can sign up either for Omniverse individual or an enterprise account. And so even for an enterprise account, you can try it out on our systems for a couple of weeks or even longer in terms of an engagement if you want to install it on your system. So as Kobus was mentioning, the configurability or the extendability shouldn't necessarily confuse or scare you, but it's basically if you want to take it on and put it on your own servers, do everything like that, you have that option. We will have options coming in the future next year in terms of if you just want to be able to go to a web browser and spin up Omniverse and do things like that as a SaaS product, then we could do that as well. But for individuals, we have, you can try it. It's for free. You can collaborate with up to 2 people on there and kind of go from there.
Thank you. There is one more comment or question. We won't have time to cover everything, but again, you have this Discord channel, but yeah, this is maybe interesting that you didn't speak about collaboration format BCF and IFC. I guess you don't need it as it's automatically everything on Omniverse.
Well, yeah. I mean, we see IFC as another application. It's a very important schema, but it fits within everything else, right? And we can import it, and we are definitely looking more closely on the functionality of it, and the same with BCF. I think BCF. Sorry, I think it's a very important way of doing markups, because what we didn't show is that we have one of the flavors of Kit is View, where we actually can do waypoints and markups and sketches and screen grab these things, and we definitely want to be enabling those in the future. But it's kind of just one step at a time, and I think right at the moment we are focusing on making sure that everybody can speak to everybody else and actually can work full-on collaboratively when we take on these as a second stage. We're very aware of these, but we also answer to many markets, and we're finding the pain points for our clients first and trying to solve those as major solutions. So.
My point was that as the other applications run already or have a bi-directional link with Omniverse, that probably, but well, yeah, you might want to import maybe some IFC files from ArchiCAD or other Visual Arc, I don't know.
Yeah,
and yeah,
we do have an ArchiCAD connector as well.
Okay.
So you can, if you're working in ArchiCAD, you could bring that information in. It's really about not replacing, again, one file type or one workflow, but embracing them all and kind of, trying to get everyone to work together.
By using Rhino Insight, all Grasshopper applications run also on Omniverse, right? Should.
Yeah. Sorry, meaning plugins from Rhino?
Exactly, plugins for Rhino and Grasshopper.
Which is, exactly. So that's what makes it fantastic is, we like I said, we all love our ladybugs and all our other plugins and so on. Wombat, etc. And so bringing that in, I mean, by connecting to Rhino, it opens it up to lots of different simulations, automated workflows, all sorts of stuff.
And on that, we have different ways to take it out. So we can take, of course, vertex shaded meshes out as well, and we can take timestamp meshes out. So you can actually do a daytime analysis, like I've kind of shown you with the generative building model. That is over a period of time, and you can put that out into Omniverse, and then you press the play button and you see that daytime animation as the sun changes, and all the related analysis behind it will be shown in respect to the time of day. So that's a really great feature, and that's also how we do some of the geometry animations through Grasshopper into Omniverse, which is brilliant. So now all of a sudden you do geometry and analysis simulations in a full ray traced model driven by Grasshopper.
I'm answering Yuneb Ahmad because he's asking where or which masters in architectural engineering or BIM engineering include Omniverse as part of the curriculum. I'm telling him to contact us on the Rhino forum or on your forum, and we will do some research I think you collaborate with many schools and universities, right?
We're getting there. I think that's something I think we have to build out some better partnerships. Some of the people on the team, myself included, are actually university professors as well on the side. So we're trying to build it out.
I think the IAC, so the Institute of Advanced Architecture in Catalonia, use it and teach it. And I guess it's the same with ICD Stuttgart, or the most important masters in the world are starting to include these new technologies in their curriculum. So now,
show quickly here, just as 1 second. Sorry, Carlos. This is a geometry inside Omniverse. This is one of the first tests we've done, and I don't want to spoil it because Robert's going to show some amazing stuff at AEC Tech and Chicago Innovate. But
we like spoilers.
Yeah, no. This is just a little taste of what is happening. So here we have a Grasshopper script, and we have geometry that could have come from anywhere in Omniverse, and we are now loading, in essence, a Rhino compute with a Grasshopper function that builds a facade on that piece of geometry. Now, again, this could be SketchUp, this could be done in Unreal, it could be done in Revit, it could be done in Rhino, it doesn't really matter. So all of a sudden, we're extending Rhino and Rhino compute to all the other applications that we have in Ecosphere and a collaboration process with. And then, of course, you can start applying the overs or the deltas that we are calling and apply materials and other functions to this and keep updating this as we kind of go along. That's just one example that I can show quickly that we've done. And I think there's another one I can load quickly in a second if you want to see that. But this is really powerful. And this is what we love about McNeel and love about Rhino, is that Rhino Compute is just so extendable. And now we're just taking that further with Omniverse.
Cool. Again, there will be also compute workshops on the two conferences you're attending, Chicago and New York as well. I think you wanted to show something else.
Yeah, let me just quickly load this. Robert wanted to show.
Robert has it. Here you have. Yep.
We have a more updated. He has a more updated one, so he's in control of these.
Okay, so I will unmute for once, and I'll just show you my latest one. So I actually show the Rhino compute happening in the background. So here is a prototype where we're starting to, it was just a very basic script. It was just a prototype, but here we're starting to unpack the inputs of a Grasshopper script and have them as a UI. So basically we have the, we have the Grasshopper script and the compute server running. And now we're just, running through sliders inside of Omniverse, and it's just computing in the background, just triggering a Grasshopper script. This is, very, very simple. But the big thing is, like, since you have full Python support, being able to do these kinds of integrations is actually quite straightforward if you kind of just understand how to do a Rhino compute integration, mostly because Rhino created such an amazing API. And so, yeah, unpacking the inputs, turning them into UI controllers, and then just being able to run compute directly inside.
Thanks, Robert. I didn't want to show that one because I want you to show it.
Such a nice case study, because, compute is still a work in progress. I mean, we are starting to see many applications. I'm also pasting on the chat about Rhino Compute for those of you who want to experiment with it. And yeah, I think we are running out of time. I think it was an excellent webinar. Again, as I mentioned before, the future is here, and it's amazing also the group of people that Nvidia has hired for this project, because we knew you already from other top AEC firms, and we were amazed when we saw that you are now part of the Nvidia team. So that means that it will be an excellent product. Many thanks again. Thanks also to the audience, to the chat moderators, and write us for both Nvidia or McNeel for any questions you might have. We will maybe cross the answers. I mean, and have a nice day and see you soon.
Thank you very much.
Thank you, Carlos. Thanks everyone for joining.
Carlos.
Bye.
Take care.
Bye.